electric cell. We are going to study electric cell, but before that you should know how the current can be produced by different ways. In this era, you have the possibilities of conversion of any energy to another energy. For getting electrical energy, you have so many options all given over here. Solar energy, you could get electric energy from solar also, from light by photocell. Thermal energy is also converted into electrical energy with the help of thermocouple. Mechanical energy by generator. But here we are emphasizing the conversion of chemical energy into electrical energy. And for that, we are going to study cell. Cell, when represented, it's two unequal parallel lines. You want to show that cell is variable, then in that case, you have to use one arrow that shows the variability of the cell. You want to combine the cell, that will be termed as battery. Battery is nothing but the combination of cells. Cell is characterized by one particular term that is known as electromotive force. You see, inside the cell, chemical reactions take place, and because of the chemical reactions inside the cell with an electrolyte, the two plates that have been immersed in the electrolyte, they get the polarity. One becomes positive, one becomes negative. The positive plate here in physics we term as anode, and negative cell is termed as cathode. We have only the criteria of the positivity and negativity for considering anode and cathode. But when it comes to chemistry, they are having a different criteria of oxidation and reduction. For example, in Daniell cell, we have copper plate. Copper plate, according to our view, is positive, that is anode. But since reduction takes place, probably they consider it as cathode. You see, cell behaves just like heat pump. What is the role of heat pump? Against the nature. What is the role of water pump? That is against the nature. Because what nature permits is the fall of liquid from higher level to lower level, the flow of heat from higher temperature to lower temperature. But heat pump will do quite reverse of this. It will flow the heat from lower to higher temperature. Water pump will carry the water from lower level to higher level. Similar is the role that of the cell also. It allows the flow of current from lower potential to higher potential inside the cell. That's why it is compared and considered analogous to heat pump. The current will flow outside the cell from positive to negative terminal like this. You see, anode is considered positive, that is positive, that's shown or represented by bigger line. This one cathode. Current is flowing this way from positive to negative outside the cell, and within the cell it's going to flow from negative to positive. Don't consider the cell as a source of charge. It will simply lend the charge. It will simply spare the charge to flow through, but ultimately that charge is going to return back to the cell. Cell is considered sometimes as source of charge, but the conception must be clear. It's not providing the charge, it's only allowing the charge to start from positive and to return to the negative. So what is the basic function of cell? It is only to maintain the flow of charge in the electrical circuit. It doesn't produce or destroy the charge. Combination of, now we can define EMF mathematically. It is the ratio of work done by the cell in flowing unit charge throughout the circuit. EMF is given as ratio of W upon Q. W could be written as power into time, and charge could be written as product of current and time. E could also be defined as ratio of power and current. Electromotive force is defined in either way. It is the ratio of work and charge. It is the ratio of power and current. Power generated by the cell and current delivered by it. So that way you have another unit also. That's watt per ampere. Whereas here you get the unit volt. Again, its name is very ambiguous. Sometimes high misconception is associated with it. It's termed as electromotive force. So you have to be particular, you have to be alert. It's not a force, it's not having the unit Newton. Actually, the influence, the factor responsible for flowing the charge from negative to positive, that's termed as electromotive force. Current is flowing from negative to positive. For that, we are using the term electromotive force represented by E, and this is always considered positive from negative to positive terminal of the battery inside the cell or battery. If you are having two cells connected this way, both will be in helping mode. One cell always is consider the current is starting or originating from anode. Here also, their current are to be added together. They will be helping each other. They will be added to each other. So, EMF, effective EMF, this one. Suppose you are having two cells connected this way, means their positive terminals are connected together in a branch of the circuit. In that case, outer the two current, one will dominate. So, we could say that the two cells are not helping each other, and we are going to get the difference of the two. We never know which one is greater. That's why I am highlighting. We have to get the difference of two EMF. Actually preparing ourselves for studying circuit at length. Now we'll gradually switch over to complex circuits. But prior to know, you must know what is a circuit. Circuit, the best way of representing a circuit. This is key. In the circuit, you have two parts. One is known as active and the other is known as passive. You see, passive part simply means that current will flow through it, like inductance, capacitance, resistance. These are known as passive element of the circuit. But the current has to be produced ultimately by some source. That source might be thermocouple, might be photocell, any source of current that we termed as active element of the circuit. So, you could say that circuits are always made of two parts, active and passive, that I have clarified at length. Now, we have covered, you see, each and every part related with the circuit. Cells are sometimes given or characterized or specified in terms of capacity. When you talk of capacity of a conductor or a condenser, their meaning is different. But when you speak in terms of capacity of a cell, it is the product of current it can produce and the time or the duration for which it can produce. For example, suppose there is a battery or cell that is capable of supplying you 10 ampere current for 3 hours. Then you could say the capacity of that cell is 30 ampere hour. This is the capacity. And above all, now I'll tell you in the last that electromotive force is the characteristic of a cell. You go to a general store shop and purchase a cell of 1.5 volt. Cell is always characterized in terms of its EMF. You have used the cell, functionals, multidimensional uses of the cell you have made, and now this cell is about to be thrown away. It has been used to the maximum. Now it's of no use for you and you want to throw into the dustbin. the time at which you are throwing the cell in dustbin, at that time also it is having the EMF 1.5 volt. And when you brought the cell, you purchased the cell, that time also it was of 1.5 volt. So when the cell is being thrown away, then also its characteristic, that is the EMF of the cell, will be set to be 1.5. Remember this thing, EMF is not going to change with the use of the cell.